Today we are going to be looking at prime factoring and finding a GCF, and these are both hopefully terms that you've heard before, you've done something with before, so a lot of this is going to be review, but if it's something that you are not sure of, make sure you're getting caught up on some of those pieces and filling in any information you may have forgot. So when we are prime factoring, what we're doing is we're writing a number as a product. Product means multiplication of its prime factors. A prime factor is any number that is only divisible by 1 and itself. Okay, so you can only divide it by 1 and itself. It can't be broken up any further. So we would say that 6 is not prime because 6 is 2 times 3, but 5 is prime because we can only write it as 1 times 5. There's no other numbers multiplied together that are integer values that will give us 5. So one of the things that is important is sort of remembering some of our division rules that we learned at the very beginning of the school year. So you can use a calculator if you need to, but some things that help is like remembering that if a number is even, it's divisible by 2. If we add up the digits and it's divisible by 3, then the number is divisible by 3. If it ends in a 0 or a 5, it's divisible by 10. So if we look at 70 and we want to prime factor it, we are going to make a tree, sort of 2 branches coming off of it, and think of 2 numbers multiplied that give us 70. Now, one person might pick 2 and 35, and another person might pick 7 and 10. It doesn't matter as long as mathematically speaking, you are picking correct values that multiply up to 70. So let's say we pick 7 times 10. We would then ask ourselves, is there anything we can split 7 into? No, we cannot, but 10 will split into 2 and 5. Now, if you say you're not very good with that, you could use your calculator and say, okay, 70, I know that that's divisible by 10, and so you do divide it by 10, so there's our 7 and 10, right? And then do the same thing with 10 and work your way down. Once we make our entire list, we are gonna then circle anything that does not have an extra branch coming off of it. So we don't wanna pick 10 because 10 has a split coming off of it, so we're not gonna circle it. But 7, 2, and 5 do not. And we're gonna write these in order from least to greatest. So 2 times 5 times 7 is equivalent to 70. And you could check that by in your calculator doing 2 times 5 times 7, and it does give you 70. So this is the prime factorization of 70. So let's look at 120. If we wanna do 120, maybe we see that it ends in 0. And so we say 10 and 12. Okay, again, you could pick something else. It just mathematically needs to be correct. We then would know that 10 could split into a 2 and a 5. 2 cannot be split up. 5 cannot be split up, but 12 can be split up. Maybe you split 12 into 2 and 6, and the 6 into a 2 and a 3. Okay, and so we're picking anything that could not be split up any further, and then again, we're writing in order from least to greatest. So we would have a 2 times a 2 times a 2 times a 3 times a 5. And this would be our prime factorization. So if we continue to apply this process to 252, as the numbers get bigger, this is where you might need to use a calculator to help you. So if you take 252 and maybe the only thing that you see is that 252 is even, and so you want to divide that by 2. That gives you 126. And then you continue that process. And then you go, okay, well, 126, that's even, so I can divide that by 2. Now, if you're not very good, you might have to try. You might have to try and divide 63 by 3, divide it by 4, divide it by 5, until you find something that works. Okay, or you could say 6 plus 3 is 9. That is divisible by 3, so we know 63 will be divisible by 3. That'll be 3 and 21. And 21 splits into a 3 and a 7. So if we pick everything that does not divide up any further, we would have a 2 times a 2 times a 3 times a 3 times a 7. And finally, if we look at our 450x squared y, now this is slightly different because it does have variables attached to it. So if we start prime factoring this, we might see that it ends in 0, and so maybe we decide we're going to divide it by 10. And if you don't know, right, that's 45, but you could put that in your calculator. It doesn't matter which one you write on which side. Okay, maybe you then know that 10 splits into 2 and 5. 45, it ends in a 5, right? So you could use your calculator to divide that by 5. And 9 will split into a 3 and a 3. So for writing this out, we're picking our numbers that don't have any branches off of it. We'll have a 2 times a 3 times a 3 times a 5 times a 5. But we're not done yet because we still need to consider this x squared y. Right? I prime factored the 450, but I still need to consider those variables. All we are going to do to prime factor a variable is write it the same number of times as exponents. So an x squared is just an x times an x. If it was x to the 7th, we'd write x times x times x, and write 7 times. And then there is a y. And so that is our prime factorization there. Now, when we are looking for a GCF, we are looking for the greatest common factor. So this is another piece that we can do with factoring, right? The greatest common factor. If you remember doing this before in past math classes, you are looking for the largest number that will divide evenly into 2, 3, 10, however many numbers there are. And there are multiple different approaches that you can take to finding the GCF. Okay, the approach that we are going to sort of look at is going to carry over into where we're moving forward in this, right? But our goal is going to be to look at the two numbers. So if we want to find a GCF of 24 and 60, we are going to ask ourselves, what's a number we can think of that will divide evenly into 24, that will also divide evenly into 60? And you can pick any number that you can think of. So all you might see is that they're both even, and so you pick to divide them both by 2. Okay, and so we'll take 24 divided by 2, which will give us a 12. And we will take 60 divided by 2, which will give us a 30. We will then ask ourselves again, what's the next number we can think of, or another number, I should say, what's a number we can think of that goes into 12 that will also go into 30? Maybe again, you see 2. And so you say 12 divided by 2 is 6, and 30 divided by 2 is 15. What's a number that goes into 6 that will also go into 15? And maybe at this point we see 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. Now, maybe you saw 3 first, maybe you saw 6 first, maybe you saw 4 first. Doesn't really matter as long as you are dividing by something correctly. When we get to this point, we will ask ourselves what goes into 2 that will also go into 5. Oftentimes my students will say nothing, but there's always something. If we can't think of anything else, then the answer to that is 1. When we get to that point, okay, so when we get to the point that all we can divide by is 1, so the only GCF here, the only number is 1, that's when we know we are done dividing. And what we will do is we will take every single number that we divided by and we are going to multiply those together. So I'm going to take 2 times 2, which is 4, 4 times 3, which is 12, and so I will say that my GCF is 12. And you know, maybe you saw 12 at the very beginning. Someone maybe saw that, someone else maybe didn't. It just depends on finding them all. So some students will see a larger number quicker than others. It just depends on the particular problem. So let's say we want to find the GCF of 84 and 26. Again, maybe we see that they're even. Okay, and if you need to use a calculator, feel free to divide that out with your calculator. It's whatever you need to do to get that number divided out and find each of these pieces. So 84 divided by 2 is 42. 126 divided by 2 is 63. Okay, you might have to do some checking at this point. They're not both even, so it's not 2, but these are both divisible by 3. Okay, so maybe you see 3 first, maybe you see something else. 14 and 21 are both divisible by 7. Okay, and then we say what will go into 2, that will also go into 3, and the only thing there would be 1. So we're going to take all the numbers that we divided by, and we are going to multiply them together. So we'll say 2 times 3 times 7 is 42. And so our GCF for these two numbers will be 42. 36 and 90. So look at this. Maybe you see a number that's larger to start with. So now maybe if you look at this, maybe you see 9 right away. And so you say 4 and 10. And then you pick a 2. Okay, the larger number that you see, obviously the less amount of work it is. But it's not that much additional work to write another row. Oops, that is an 18. 9 times 2 is 18, so our GCF here is 18. We can do this process if there are 2 numbers, if there are 3 numbers, if there are 100 numbers. It is the same no matter what. So if we look at this situation, there are now 3 numbers. So we want to think of a number that will divide evenly into 30, 45, and 255. So maybe we see that they all end in a 0 or a 5, and so we decide to divide by 5. And I'm going to do 255 divided by 5, which gives us a 51. Now, be very careful because you might say, oh, I don't see anything else. But 5 plus 1 is 6, so this is divisible by 3. Give us a 17. There is where we can't divide by anything else. And again, you might have to do some more checking. You might have to try 2, try 3, try 4. So we multiply. 5 times 3 is 15. So our GCF on this one is 15. Now we can do this same process if we have something that involves variables. Our process is going to be very similar. So we are going to look at 27 and 99 and ask ourselves if we can think of a number that will divide evenly into both of them. So now I'm just focusing on the 27 and the 99, and maybe I can think of 9. Okay, before I start dividing, I am then going to focus on the variable. Okay, the first thing that has to be true is that they both have to have the variable. If they do not both have the variable, then it cannot be part of your GCF, right? It has to be a common factor. But they do both have that x, which means I can divide by an x. And we are going to take out the smaller exponent. Okay, this one over here has 3 x's, and this one over here has 2 x's. So how many x's would they have in common? Well, they would end up having 2 x's in common. If one has 3 and one has 2, there's 2 of them that they would share. Now remember, our rule says when we divide, we subtract. So we're doing 27 divided by 9 like normal, and 99 divided by 9 like normal, except we're saying 3 minus 2 is there's an x left there, and 2 minus 2 is no x's. Okay, so then same thing. What goes into 3, that will also go into an 11. Well, there's our 1. And then we check and see, do they both have the x? No, they do not. So we have our GCF. It is 9x squared. So if we do that same thing over here on this last one, right, what will go into 66? That will also go into 36. And maybe we choose 6. Okay, then we'll check the variable. They do both have the d, and we are going to take the smaller one. So that will be our d to the 4th, right? We're checking to make sure that they both have the variable. And then we are using the smaller exponent. Okay, so we're going to divide that out. 66 divided by 6 is 11. We subtract our exponents when we divide, so that cancels out. 36 divided by 6 gives us 6. Again, we subtract our exponents. 6 and 11 only have a GCF of 1, and they do not both have the variable, so our GCF is 6d to the 4th.